single conductor cable, as per the requirement, must be 1/0 American wire gauge or larger and of a type listed and marked on the surface for use in cable trays. This requirement means that the single conductor cable must be listed by a nationally recognized testing laboratory for use in cable trays. It must also be specifically identified as being suitable for cable tray use by markings on the exterior surface of the cable jacket. An example of a marking that would indicate that a cable is listed for use in cable trays is the explicit text "use in cable trays only." This requirement applies to all single conductor cables that are installed in cable trays. This includes both new installations and upgrades to existing installations. Power and control tray cable, known as Type TC, is a specific type of cable assembly that is designed for use in cable trays. It consists of multiple insulated conductors under a non-metallic jacket. The requirement for single conductor cables does not specifically refer to Type TC cables because Type TC cables are a type of multiple conductor cable assembly. The requirement applies to single conductor cables. Therefore, a single conductor cable that is used in a cable tray must be listed and marked for cable tray use, even if it is not a Type TC cable. The National Electrical Code, or NEC, outlines specific requirements for electrical installations to ensure safety and proper functionality. Article 392 addresses cable trays, which are structural systems used to support insulated electrical cables and raceways. Section 392.3 details the uses permitted for cable trays, and understanding these regulations is crucial for compliant installations. When dealing with single conductor cables in cable trays, a key requirement is that cables of size 1/0 American wire gauge or larger must be of a type listed and marked on the surface for use in cable trays. This stipulation ensures that the cable is suitable for the environmental conditions and mechanical stresses associated with cable tray installations. The phrase "type listed and marked on the surface for use in cable trays" has significant implications. Firstly, listed means that the cable has been evaluated and certified by a nationally recognized testing laboratory such as Underwriters Laboratories, or UL, or Intertek, or et al., to meet specific safety standards. Secondly, marked on the surface signifies that the cable's outer jacket or insulation must bear a visible marking indicating its suitability for cable tray use. This marking typically includes phrases like "suitable for cable tray use," or simply TC. The presence of this marking provides assurance that the cable has been designed and tested to withstand the rigors of a cable tray environment. For instance, a cable listed for cable tray use would have passed tests for crush resistance, impact resistance, and resistance to environmental factors such as sunlight and moisture. The markings also serve as a quick reference for inspectors and installers, ensuring that the correct type of cable is being used in the application. The NEC definition for power and control tray cable Type TC specifies that it is a factory assembly of two or more insulated conductors, with or without associated bare or covered grounding conductors, under a non-metallic jacket. This definition makes it clear that Type TC cable is a multi-conductor cable assembly, not a single conductor cable. Therefore, the requirements for single conductor cables in cable trays, as specified in 392.3 B1a, are distinct from those for Type TC cables. Single conductor cables used in cable trays must independently meet the listing and marking requirements for cable tray use, irrespective of whether they are part of a Type TC assembly. In existing installations, upgrades often involve replacing or adding cables to accommodate increased power demands on new equipment. When upgrading an existing cable tray system, it is essential to verify that any new single conductor cables meet the current NEC requirements for cable tray use. This includes ensuring that the cables are of the appropriate size, typically 1/0 American wire gauge or larger, and that they are listed and marked for use in cable trays. Additionally, it is important to inspect the existing cable tray system for any signs of damage or deterioration, such as corrosion, broken supports, or inadequate spacing. Addressing these issues during the upgrade can prevent future problems and ensure the continued safety and reliability of the electrical system. The requirements for single conductor cables in cable trays are not limited to new installations. They also apply to upgrades to existing installations. When adding or replacing single conductor cables in an existing cable tray system, it is essential to ensure that the new cables meet the current NEC requirements for cable tray use. This includes verifying that the cables are of the appropriate size, typically 1/0 American wire gauge or larger, and that they are listed and marked for use in cable trays. In addition to complying with the NEC requirements, it is also important to follow the manufacturer's instructions for installing single conductor cables in cable trays. This includes proper spacing, support, and termination techniques. Incorrect installation can lead to cable damage, overheating, and other safety hazards. In summary, the NEC requirements for single conductor cables and cable trays are designed to ensure safety and reliability. By understanding and complying with these requirements, electrical professionals can ensure that cable tray systems are installed and maintained in a safe and effective manner. This involves selecting the correct type of cable, verifying its listing and markings, and following proper installation practices. In addition to the points already covered, it's beneficial to elaborate on the practical implications of these requirements and offer additional examples to reinforce understanding. Let's start with the selection of appropriate single conductor cables for cable tray use. When choosing cables, electrical professionals should consult the manufacturer's specifications to ensure that the cables are specifically designed and tested for cable tray applications. These cables typically have enhanced insulation and jacketing materials that provide superior resistance to abrasion, chemicals, and environmental factors. For example, some cables may be constructed with cross-linked polyethylene or XLPE insulation, which offers excellent electrical properties and heat resistance. Others may feature a nylon jacket for added mechanical protection. In addition to the use in cable trays only marking, other common markings may indicate compliance with specific industry standards, such as those set by the Institute of Electrical and Electronics Engineers, or IEE, or the Insulated Cable Engineers Association, or ISA. These standards define performance criteria for cables used in various applications, including cable trays. For instance, a cable marked with IEE 1202 indicates that it has passed a flame propagation test, demonstrating its ability to resist the spread of fire. Proper installation techniques are crucial for maintaining the integrity and performance of single conductor cables in cable trays. Cables should be supported at regular intervals to prevent sagging and excessive stress on the conductors. The NEC specifies the maximum allowable spacing between cable supports, which varies depending on the size and type of cable. For example, cables with a diameter of 1 inch or less typically require supports every 6 feet, while larger cables may require more frequent supports. When routing cables through cable trays, it's important to avoid sharp bends and kinks, as these can damage the insulation and reduce the cable's current carrying capacity. Bending radii should comply with the manufacturer's recommendations and industry standards. Additionally, cables should be securely fastened to the cable tray to prevent movement and abrasion. Cable ties, clamps, and other fastening devices should be made of materials that are compatible with the cable jacket and the cable tray material to prevent corrosion and degradation. Proper termination techniques are also essential for ensuring reliable electrical connections. Single conductor cables should be terminated using connectors and lugs that are specifically designed for the cable type and size. Termination should be made in accordance with the manufacturer's instructions and industry best practices. It's important to ensure that terminations are properly tightened and insulated to prevent loose connections, arcing, and other safety hazards. Regular inspection and maintenance are necessary to identify and address any potential problems before they escalate. Cable tray systems should be inspected periodically for signs of damage, corrosion, or deterioration. Cables should be checked for abrasion, cuts, and other forms of damage. Termination should be inspected for looseness, corrosion, and overheating. Any issues identified during the inspection should be promptly addressed to prevent further damage and ensure the continued safety and reliability of the electrical system. In addition to visual inspections, electrical testing can be used to assess the condition of single conductor cables in cable trays. Insulation resistance testing, for example, can detect degradation of the cable's insulation, which may indicate the need for replacement. Continuity testing can verify the integrity of the cable's conductors and terminations. Thermographic imaging can identify hotspots caused by loose connections or overloaded cables. By incorporating these additional details and examples, the explanation becomes more comprehensive and practical, providing electrical professionals with a deeper understanding of the requirements for single conductor cables and cable trays. Remember to always consult the latest edition of the NEC and other relevant standards for specific requirements and guidelines. Let's further expand on the practical aspects and considerations for selecting, installing, and maintaining single conductor cables and cable tray systems. One critical factor to consider is the environmental conditions to which the cables will be exposed. Cable trays may be located indoors or outdoors, in dry or wet environments, and may be subject to extreme temperatures, chemical exposure, and other harsh conditions. Selecting cables that are specifically designed to withstand these conditions is essential for ensuring long-term reliability and safety. For example, cables installed in outdoor cable trays should be sunlight resistant and capable of withstanding wide temperature variations. Cables installed in wet or corrosive environments should be moisture resistant and chemically resistant. The cable jacket material plays a crucial role in protecting the cable's conductors and insulation from environmental damage. Common jacket materials include polyvinyl chloride, or PVC, polyethylene, or P, and thermoset polymers. Each material has its own advantages and disadvantages in terms of cost, flexibility, chemical resistance, and temperature range. Another important consideration is the ampacity of the cable, which is the maximum amount of current that the cable can safely carry without exceeding its temperature rating. The NEC provides ampacity tables for various types of cables based on their size, insulation type, and installation conditions. It's essential to select cables with sufficient ampacity to handle the expected load current, taking into account any directing factors for ambient temperature, conduit fill, or other conditions. Overloading a cable can lead to overheating, insulation damage, and even fire. In addition to ampacity, voltage drop is another important factor to consider, especially for long cable runs. Voltage drop is the reduction in voltage that occurs along a cable due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to a maximum of 3% for branch circuits and 5% for feeders. To minimize voltage drop, it may be necessary to use larger cables or run multiple cables in parallel. Proper cable routing is essential for minimizing stress and strain on the cables. Cables should be routed in a way that avoids sharp bends, kinks, and abrasion. Cables should be supported at regular intervals to prevent sagging and excessive weight on the cable tray. The NEC specifies the maximum allowable spacing between cable supports, which varies depending on the size and type of cable tray. When installing cables and cable trays, it's important to maintain adequate spacing between cables to allow for ventilation and prevent overheating. The NEC provides guidelines for cable spacing and cable trays based on the cable size and ampacity. It's also important to avoid mixing different types of cables in the same cable tray, as this can lead to compatibility issues and corrosion. Proper cable termination is essential for ensuring reliable electrical connections. Cables should be terminated using connectors and lugs that are specifically designed for the cable type and size. Termination should be made in accordance with the manufacturer's instructions and industry best practices. It's important to ensure that terminations are properly tightened and insulated to prevent loose connections, arcing, and other safety hazards. Regular inspection and maintenance are necessary to identify and address any potential problems before they escalate. Cable tray systems should be inspected periodically for signs of damage, corrosion, or deterioration. Cables should be checked for abrasion, cuts, and other forms of damage. Terminations should be inspected for looseness, corrosion, and overheating. Any issues identified during the inspection should be promptly addressed to prevent further damage and ensure the continued safety and reliability of the electrical system. By incorporating these additional details and considerations, the explanation becomes even more comprehensive and practical, providing electrical professionals with a deeper understanding of the requirements for single conductor cables and cable tray systems. Always consult the latest edition of the NEC and other relevant standards for specific requirements and guidelines.